Okay, so in section 4.5, we're going to continue using the two interest formulas that we used in the previous sections for compound interest. So A equals P times 1 plus R over N to the NT. That's when interest is compounded a set number of times per year or per number of years. And then the other one is when interest is compounded continuously. So A equals P times E to the RT. So we're going to use these two formulas again. The difference is that we will be looking for one of the variables that's in the exponent this time. So usually we'll be solving for time. So let's look at an example. So a sum of $5,000 is invested at an interest rate of 5% per year. Find the time required for the money to double if the interest is compounded according to the following method. So first, if it's compounded semi-annually. Okay, so let's start with the principal, $5,000. Our rate is 5%, so that's 0.05. N is the number of times per year, so semi-annually means 2 times per year. We are looking for time, so this is our unknown variable. And in this case, we know the amount that we're going to have at the end, right? We want it to double, so that means the amount that we should have at the end is $10,000. Okay, so because we have a set number of times per year that it's going to compound, we want to use this first formula here. So A equals P times 1 plus R over N to the NT. Okay, so at the end we're going to have $10,000. We start with 5,000. We know the rate, the number of times per year. We don't know time. Okay, so this is an exponential equation. Our variable is in the exponent. We want to isolate the base. The base in this case is this entire parenthesis and the exponent. Okay, so the first thing I'm going to do is move the 5,000. So it's 5,000 times this parenthesis, so I'm going to divide both sides by 5,000. Okay, so 2 equals 1 plus 0.05 divided by 2 to the 2t. Once we get here, we have our base, we have our exponent. We want to take the log of both sides. So the log of 1 plus 0.05 over 2 to the 2t. The 2t can come down to the front. 2t times the log of, let's see, what is 1 plus 0.05 divided by 2? All right, let's just write this as point. Okay, now to solve for t, I want to divide by 2 log 1.025. Divide by 2 log 1.025. Okay, so I find out that t equals, now I'm just going to type it in my calculator, so the log of 2 divided by, and I'm going to make sure when I type it in my calculator that I put a parenthesis around this whole part, because that whole thing is the denominator. Okay, and I find out that t is pretty close to 14. So I would say 14 years. All right, so that's the first one. Okay, so part B is it is compounded continuously. So that means we need this formula. Okay, all my variables are going to be the same because I want it to double. So 10,000 equals 5,000 times e to the 0.05t. All right, another exponential equation. So There is my base and my exponent. That's what I want to isolate. I want to get rid of the 5,000. It's 5,000 times e. So I'm going to divide both sides by 5,000. So 2 equals e to the 0.05t. Okay, so I've isolated my base and exponent. Now I want to take the log of both sides. Because I have e, I'm going to take, oops, what happened there? I'm going to take the natural log of both sides. So the natural log of 2 is equal to, so natural log of e to the 0.05t, the natural log of e, those cancel, and I'm left with just 0.05t. And then to solve for t, divide by 0.05. So my guess is we're going to get something less than 14 years. Because we're compounding continuously, it should take less time to double. So let's just put this in the calculator. The natural log of 2 divided by 0.05 is 13.86. Okay, so a little less than 14 years. I'm just going to leave it like this. Okay. All right, and then one more example. Now we're given a certain amount instead of doubling. Okay, so we have a sum of $10,000. It's invested at 4% per year. We want to find the time it takes to grow to $4,000 if it's compounded continuously. Compounded continuously means we need this formula. Okay, our final amount's going to be $4,000. We're starting with 1,000, and my rate is 0.04. All right, so I'm going to fill all those in here. So 4,000 equals 1,000 e to the 0.04t. Okay, I want to isolate my exponent and base. So I want to divide both sides by 1,000. Okay, so 4 equals e to the 0.04t. I've isolated my base and exponent. Now I want to take the natural log of both sides because I'm dealing with e. So the natural log of 4 equals 0.04t, and then just solve for t, divide by 0.04. So t is going to equal, let's see, the natural log of 4 divided by 0.04. So 34.7 years. It's going to take a while.